Welcome to Brain Vision.
In this problem, we're going to be looking at polarized light. It's traveling this direction, and it's horizontally polarized. So in this direction here. And it's going to pass through this polarizing sheet. So we'll draw a polarizing sheet like so, which has a transmission axis that's some degrees off the horizontal. So if this is our horizontal, the transmission axis here is going to be some degrees theta. So that the light that passes through this polarizer, because it's slightly off the horizontal, there'll be a smaller intensity of light that passes through. And what we want to figure out is, what is that angle theta? Well, they've given us the initial intensity here. So we'll call it S naught. That's the average of the incident intensity, 0.883 watts per meter squared. And the average intensity that emerges from the polarizer, 0.764 watts per meter, slightly less. Now, the equation that we're going to use to relate all these things is average intensity equal to the average incident intensity times cosine squared theta. And so to solve for theta, what I'll do first is rearrange this equation a little bit. Divide both sides by the incident intensity. That's equal to cosine squared theta. And then we can take the square root of both sides. We get that cosine theta equals square root of the average intensity divided by the incident average intensity. Now to solve for theta, I'm going to bring it over here. All we need to do is take the cosine inverse of both sides. So cosine inverse of cosine theta, so that the cosines cancel out. Cosine inverse on the other side. And what we get is that theta is equal to the cosine inverse of the square root of the average intensity divided by the average incident intensity. We can go ahead and just plug in values for those two intensities. Take the square root, take the cosine inverse, and you'll find that theta is equal to about 21.5 degrees.